Example 5, an integral interpreted as a net area. We want to find the integral going from 0 to 2 of the function 2x cubed minus 6x plus 3 over x squared plus 1 dx, and interpret the result in terms of areas. So here we have the integral going from 0 to 2 of the function 2x cubed minus 6x plus 3 over x squared plus 1 dx. Okay, so if we take this step by step, okay, finding the antiderivative of each particular function, okay, we know that if we take a look at 2x cubed, well, the antiderivative of 2x cubed is going to be 2x to the fourth over 4, which then simplifies to 1/2 x to the fourth. Okay, what is the antiderivative of minus 6x? Well, this is going to be minus 6x squared over 2, which simplifies to negative 3x squared. Now, what is the antiderivative of 3 over x squared plus 1? Well, that's the same thing as 3 times 1 over x squared plus 1, which means that this is going to be plus 3. Now, the antiderivative using the tables of 1 over x squared plus 1 is the tangent inverse of x. So this becomes plus 3 times the tangent inverse of x. So now let's go ahead and write this here. So what we have is we have 1/2 x to the fourth minus 3x squared plus the tangent inverse 3 times the tangent inverse of x. And we're evaluating this at from 0 to 2. So what that means is we're going to have to plug in 2 for each value of x and then subtract the function again at 0. So we have 1/2 times 2 to the fourth minus 3 times 2 squared plus 3 times the tangent inverse of 2. And then minus, this is going to be 1/2 of 0 to the fourth power minus 3 times 0 squared plus 3 times the tangent inverse of 0. Okay, so if we take 2 and raise it to the fourth power, that is 16. If we take half of 16, that's going to give us 8 minus, this is 2 to the square, so it's 4 times 3, which is going to give us minus 12. Okay, and then this is going to be plus 3 times the tangent inverse of 2. Okay, and on this side, everything is going to become 0, so that's 0. Okay, now let's simplify this a little further. 8 minus 12 is negative 4 plus 3 times the tangent inverse of 2. Okay, or if we wanted to find the approximation of this value by plugging it into the calculator, then we would get negative 0.67855. So therefore, this would represent the net area, or the net area of this particular integral. Okay, so let's take a look at what this graph would look like on Desmos. Okay, so we have 2x cubed minus 6x and then that's plus, we have 3 divided by x squared plus 1. Okay, so there's our function, but we know it's going from 0 to 2, so let's put in that restriction. So our lower limit is 0. Okay, and then it's going to 2. So therefore, here is our graph. Okay, so that means that what we have, and let's go ahead and put in some vertical and horizontal lines here. So I'm going to put in a vertical line at x equals 0, just so we can see what's happening. Okay, and then we have a vertical line at 2. Okay, and then we have a horizontal line at 1.106. I'm sorry, a negative. It should be a negative there. Maybe not. Negative 2.581. Okay, so here's what our graph would look like. So what that means is we have some things that have to be shaded up above and below. So technically that means we're going to have an area where we add the top and then subtract the bottom. Okay, so if we take a look at this graph, here's what this looks like. Okay, going from 0 to 2. So let me go ahead and just expand this a little bit with our requirements here. I'm going to get rid of the pi. Okay, and then we're going to just go from 0 to 2. Okay, so now we can see what this graph looks like, very similar. So here, we can see that we have the area here right below the function, which is the positive here, and then we have our area here that's positive, and then everything underneath here is negative. And so in this figure, it shows the graph of the integrand. So we know from section 5.2 that the value of the integral can be interpreted as a net area. The sum of the areas labeled with a plus sign minus the area labeled with a minus sign.